In this video, we're going to look at the periodic table and how it's arranged. The periodic table is arranged by mass, and so we start with the lightest element and go on to the heaviest. So hydrogen here is the lightest element, weighing 1, and then we go across, and as we go down the periodic table and across the periodic table, the elements get heavier. They are arranged in such a way that elements in the same group, which would be column like this, behave the same way. So we call it the periodic table because there is periodicity to how these elements behave. So a group or a family, as I mentioned previously, is a column. And in a given column, the elements in that column tend to behave the same way. So, for example, in this first column here, if I start with lithium, if I throw a chunk of lithium metal into water, it will kind of fizz around. If I throw sodium in there, it will fizz around and maybe even catch on fire. And if I throw potassium in there, it will definitely catch on fire. All of these are water reactive. And I think in lab we might let you throw some, or at least watch us throw some in the water. And so that's what I mean when I say that periodicity in this table. All of these elements that are in one group are going to behave like one another. So down a column is a group, and they have similar properties and behaviors to one another. So as we go across the periodic table, we have periods. So, for example, I'm going to outline the third one right there. So the periods are across the periodic table. And as you can see here, if I looked at sodium, it has 11 protons. If I go to the next one, then there's 12 protons and 12 electrons. And if I keep going on to aluminum here, there are 13 protons and 13 electrons. So as we go across the periodic table, one additional proton and electron is being added to each element. So on the left-hand side of the periodic table are the metals. And we will see as we go on that the metals tend to lose electrons when they react. And then on the right-hand side of the table would be the nonmetals. And the nonmetals tend to gain electrons when they react. So you can see here we have this sort of color-coded key to tell us metals. These guys in the middle here are called the transition metals. You see transition elements above them. They're also the metals. And then we have this line here, this kind of zigzag black line that goes between the metals and the nonmetals. And there are species in between that sort of have the properties of both a metal and a nonmetal. So they're sort of morphing from one to the other. So you see as this is arranged that we have metals on one side and nonmetals on the other. So we have that periodicity again. If we take a look at any given symbol here, so let's look at argon here. So argon is Ar, so that Ar is the chemical symbol for argon. So we don't have space to write their full names out, so we have a symbol for them. The number on the top is going to be the atomic number, which is the number of protons, and that's what makes that given element, the element that we see. And then on the bottom there, that number is just going to be the atomic mass. So if we remember back when we talked about electrons, protons, and neutrons, the protons and neutrons are so much larger in size and mass than the electrons that the mass is basically from the protons and the neutrons. So 39.95 is the number of protons plus the number of neutrons.